Okay, over here we will give the model analysis for the balance control of this pendulum system. Okay, so this side is all the model parameters. Okay, you can find the description of these parameters over here. Okay, so these are all the descriptions. And over here, once you have these parameters, you can have A, B, C, D, which are the state space matrices, and they are all calculated through these parameters. And this is also in this open loop analysis over here. This is state space matrices, and this is the pole zero mapping of the transfer function in correspond to this open space state space matrices. Okay, we can see there are 4 poles in total, all on the x-axis, which are all real numbers. Okay, and there's 1 at 0. Okay, and if we run the simulation, so over here this is 1. Okay, that's the default value. Okay, if we run the simulation, it should give you the step response as this. Okay, so this is the arm degree. It will change like this. And if we change the moment of inertia, over here it's 0.00030177, and if we simply change it to 10 to the power of -5, so there are 4 zeros ahead of 1. Okay, and now we can see the pole values are changed. Okay, so you need to explain why they are changed, and if you can calculate these values as well according to these formulas. Okay, so this is the first one, and the second one is by changing this Q value. Okay, and over here this is the default value and this is the default waveform, and if you change the Q value, this one to 10, there's a typo over here. It's not 5, it's 10. So you will see the waveform is changed. Okay, and if we continue to change this to 0, or previously it's supposed to be, so all the default value over here are all ones. Let's view this waveform one more time. So it will change more slowly. Let's wait for a complete cycle. Okay, now we change this to 10, and you'll see the response will be faster than if it is only 1. Okay. And if we change this one to 0, it will become, the response will respond even faster. Okay, and there's still also a little bit damping over. We can see a little bit under damping over here. Okay, and then if we change this value even larger, we can see the response time is shorter. And if we need to meet this requirement that peak time is less than 0.75 seconds, the motor voltage, which is over here, is less than 12 volts, and the pendulum angle is less than 10 degrees. Okay, so right now it's about, over here it's about 8.9 seconds for the peak time, but the rest of the meeting the requirements. So we change this Q a little bit larger to say 40, and now we can see a faster response, and this one looks like it's smaller than 0.7 seconds. Okay, and now you need to observe the Q value and the R value, which is unchanged, and you can see the changes of this optimal gain